Mark Stewart present the first talk for the epilepsy and cognitive impairment.
All right, so sorry for the disturbance, and we'll go through a couple of these talks before lunch, I suspect, but
Really?
my name's Mark Stewart, and the next session is on epilepsy. We've got 11 talks in 90 minutes, so I'm going to be holding myself and the others pretty tightly to the 8-minute timer. Did you start a timer, Todd? Thank you.
Yep.
So what we've spent a lot of time working on and what I'll talk about today is sudden death and epilepsy. And just by way of orientation, this is an old definition that was published in the late 90s. It's been updated in the around 2012, but the main changes to that definition reflect the quality of evidence, not so much the features of the definition. And what you can see here is some places where the definition is not terribly helpful in terms of putting together some ideas about the underlying mechanism. The first point that I'll make is number one, the victim suffered from epilepsy. And so in order to be diagnosed with epilepsy, you have to have had several seizures. So if the first seizure you have or the second seizure you have is the seizure that kills you, you won't be considered having died from sudden death and epilepsy, and so that's going to be a missed case. If you look further down, some of the things are a bit obvious in terms of the name. The individual died unexpectedly. The death occurred suddenly. If you get down to number 5, an obvious medical cause of death was not found. And this is where the definition ends up looking a lot like a diagnosis of exclusion. So if you have underlying heart disease and you're found dead, it's possible your death gets labeled as a heart-mediated event and not flagged as sudden death in epilepsy. So this is roughly by orientation where we were. And so what you heard earlier is that I was involved in some work in hippocampus, and one of the things that was really great for me in hippocampus was the use of an anesthetic called urethane. I don't like behaving rats. They bite me. I've been bitten a lot. I have actually modified gloves so they can't bite through the leather. One of the great things about urethane is that it permits certain kinds of very interesting polysynaptic activity like epileptic seizure activity. And so an animal anesthetized with urethane can actually have an epileptic seizure and look a lot like this pointer on the table while it's convulsing. So the motor activity is gone, and what that allowed were some very interesting studies to take place. So we had looked at autonomic activity and the bad things that could happen as a seizure spreads into brainstem to influence the autonomic centers. Among those are some very severe cardiac arrhythmias, things like asystole. But when asystole occurs, the seizure is not supported any longer because the cardiac output drops to 0, the seizure stops, the stimulus for the asystole goes away, and the seizure ends. The asystole is restored, and so effectively you can't die from that. We looked at ways to get into ventricular fibrillation where you'd need someone to resuscitate you, and it turns out that in order to get into ventricular fibrillation, you need some very peculiar circumstances to occur, and that's part of the reason why the frequency of VFib-associated deaths in the sudden death context are so rare. What got us going was some work that actually started with Richard Colmar and some of our colleagues in otolaryngology, where they were working out ways to study the airway. And this is a movie of the top of the airway in a rat that's having a seizure. And what you'll see is abnormal movement. The pointer here, these essentially bright areas framing a V are the vocal folds, and normally they open and close very smoothly with each breath. What you'll see here, because this is taken during a seizure, can I start this time? That part of it. Maybe you can't see things.
You might need to change to the pointer.
Yeah, let's get
Off.
The pointer.
Yeah.
Manual, the separate pointer.
Maybe he'll do it.
You can just play this.
Sometimes just the space bar.
Well, I'll tell you what happens. All right. That's all right. So what happens is, instead of this airway opening and closing with each breath, what you see is during the seizure activity, the two sides are essentially chattering. At a certain point, they'll close and completely block the airway. And so what we were able to see, essentially for the first time during a seizure, is the airway actually close to generate a period of obstructive apnea. And that period of obstructive apnea can last long enough for the animal to arrest. And what I mean is respiratory arrest. And what I mean by that is, when you look at their attempts to breathe, they attempt to breathe while the airway is closed up to a point. And that point where they quit is a way for us to define respiratory arrest. But my clinical colleagues say this is ridiculous. You're using urethane and drugs to cause seizure activity, etc. So a way to get away from some of those confounds is a different study where we use the most commonly studied mouse model of sudden death, the DBA2 audiogenic seizure-prone mouse. And again, in collaboration with Richard Colmar and our otolaryngology colleagues, what we did to test this hypothesis that the mice were dying from obstructive apnea is put in a tracheal tube that's shaped like a T, so we could either close the stem, which was externalized, or leave the stem open. And this way, if the airway closed naturally, if the external stem was closed, they'd have a completely closed airway and they ought to die just like an animal without an implant. If the external tube was open, they'd have a surrogate path where they could bypass the closed airway at the top. What you see in the bottom left is a plot showing that if your airway tube is closed, the two left-hand bars, you die, the red bars. But if your airway tube is open, you have a higher chance of living. But what you see there is that not everybody lives. And part of the reason for that is not because you don't need the airway, it's because the animals during the tonic phase of the convulsion, they're not breathing very effectively. The nice thing about these mice is their seizures are very stereotyped. What I mean by that is if you give a mouse a seizure, the next time you give it a seizure, it'll look exactly like the last time. So we can pick animals that actually survived with an open tube and test them more selectively. So that's the green arrow that's taking just the green bit of bar from the third bar. When you retest those animals, you leave the tube open or you close the tube. Now you see essentially the perfect efficacy of the tube. What this work led to was our using rodent data, rat and mouse data, to actually demonstrate that the same phenomenology occurs in people. And the way we were able to do that is, in 2013, Philippe Rivlin and a group of epileptologists curated the data that they had from epilepsy units throughout the world, summarized that data with 10 spectacularly clean, well-documented cases. In their data set, you see the exact same features, and I won't explain all of those here, that pointed to obstructive apnea that we see in both the rat and the mouse model. So our conclusions, which are based on the data that I showed you, plus lots of other data, are that you can actually avoid sudden death altogether if you start oxygen at the beginning of a seizure. That's enough to delay the time between the period of obstructive apnea onset and respiratory arrest so that the seizure in most cases will end normally. If you're not able to do that, we're emphasizing the importance of waiting for the airway to be open. There are some things you can do to increase the chances of that opening. And then if you don't have that access, then cardiopulmonary resuscitation works. But the key is you need to know to be ready to perform that. And in fact, the Rivlin data shows that if you do CPR right after, within 2 minutes or so, everybody survives. So we've been able to actually take some interesting rodent model and move it all the way to the point where we're making some recommendations for first aid. Hey, I'm on time. All right. So with that, I'll stop and get to the others in our session.